Now we will talk about energy. First we are talking about kinetic energy. We are talking about kinetic energy. Again, we have two postulates. One, kinetic energy means half mv square, and you know that means you want to calculate half m. We are talking about again nth orbit, half mv square. So from where we are getting kinetic energy? It is moving, and we know the speed of electron. So now we have one formula, it is getting speed because particle need a centripetal force which he is getting from electrostatic attraction 1 upon 4 pi epsilon naught q1 q2 by r square. Cancel Rn with Rn. First we will discuss in terms of Rn. After that we are able to put the value of Rn. You will get exact value. We will use that result. Multiply both sides by 1 by 2. So half mvn square for 1 upon 4 pi epsilon naught. I am putting k. So easy to remember you. Its value is 9 into 10 to the power 9. K ze square by 2 Rn. It is kinetic energy. We know Rn, so we can write it. It is the formula for kinetic energy. Why I am writing in this way? So that you can attempt some problem easily. What is the formula for potential energy? You know the potential energies formula. What is the potential energies formula? Minus 1 upon 4 pi epsilon naught q1 q2 by r. What we are getting? Same thing, only difference of 2. So what should be total energy? They are framing problems on this concept. So that's why I am telling in terms of this, not putting the value of Rn. Total energy, add this and this. Take kz square, kze square by Rn common. You will get 1 minus. From this, it is not 2, this. It is minus 1. From that we will get plus 1 by 2. So what we are getting? Total energy negative kze square by 2 Rn. So remember this concept कि total kinetic energy means kinetic energy and total energy are same in magnitude, means they are framing problems. So I am writing here magnitude of kinetic energy and modulus of potential energy is same. The total energy is same. Magnitude of total energy and kinetic energy is same. If you remove this minus sign, it will become same formula. But magnitude of potential energy is double the magnitude of kinetic energy. If you multiply kinetic energy by 2, you will get this. What they are doing, sometimes they are saying कि in that orbit electron has energy this, suppose minus 3.4 electron volt. What should be its kinetic energy? Just remove minus sign. Kinetic energy is plus 3.4 electron volt. Getting my point? They can frame this. So now we have the formula for total energy in terms of this. Total energy in nth orbit is minus k means 1 upon 4 pi epsilon naught. Numerator ze square, denominator 2 into Rn. I am going to put the value of Rn. So what we are getting in numerator, minus ze square divided by 8 pi epsilon naught into Rn. What is the value of Rn? It was h square epsilon naught, h square epsilon naught n square, h square epsilon naught n square divided by pi e square mz, pi e square mz, mz. So what we are getting, remove z and n. So what we are getting, pi with pi, cancelling this, minus is as it is, z, removing z, I will write in last. So in bracket what we are getting, e raised to the power 4 into m divided by 8 epsilon naught square h square. After that, in numerator z square, in a denominator n square. So we are getting this number, me4 8 epsilon naught square h square. Again what we are doing, same what we did in velocity, multiplying and dividing by ch. Multiplying and dividing by ch, what we are getting, e4 m divided by 8 epsilon naught square h square. Now it will become h cube c, z square, it is z square by n square c h. But energy is, energy of, we can write hc by lambda. What is energy? H nu, and h nu we can write hc by lambda. We are talking about nth element, so we are writing lambda n minus E4m divided by 8 epsilon naught square h cube c z square by n square. Or we will do one more thing, not writing this, going to next page. It is energy in nth orbit. It is energy in nth orbit. If we calculate the value of this E4m upon this, all things are constant. E4 m 8 epsilon naught square h cube c. This is represented by r. This constant is represented by r, is known as Rydberg's constant. R is known as Rydberg's constant. Rydberg's constant. If you going to calculate its value, R's value, you will get 1.097 into 10 to the power 7 per meter. It is known as Rydberg's constant. So now, we discussed previously that when electron is moving in a orbit, it is not emitting or not radiating any type of energy. But if it is getting energy from some external source, it will jump into higher energy level. But very soon it will come back by emitting that energy in form of photons, light. It is the source of light. Now, if electron is jumping from f orbit to I orbit, we are using two words. Initially it was, after getting some energy, it jumped to this energy level. Now its position is this, and now it is coming back by jumping in finally NF. It is jumping from Ni to NF. What it will do? It will emit the difference of these two energy levels. If it is jumping from third to second, we know from this formula, this is the formula, big value of n means small numerical value of this, but minus sign is there, so it means big value of n means big value of energy, because in minus, if numerical value is decreasing, means number is increasing. So in higher, that's why we are saying third orbit is higher energy level than second orbit. Going to getting energy means going to higher energy level means jumping into a orbit which have higher quantum number. So now if electron is jumping from Ni to Nf, it will emit the energy which should be equal to difference of these two energy levels. By the formula, what we are getting, delta E should be equal to Ni means, we have this formula, minus R Z square Ch by N square, minus R Z square Ch, which is constant for all orbits, by N square, means Ni square, minus minus plus R square Z square Ch by N F square. So what we are getting, electron will emit photon of energy, this, take RCH, all that things common, R square, Z square, CH common. What we are getting? 1 upon NF square, final destination, minus from where it is coming, Ni square. Okay, so we are getting this. But change in energy is form of photon, so it should be equal to Hc by lambda. No, it was not R square, it is R. It is not R square, it is R. So what we are getting now, Hc by lambda is equals to Rz square, 1 upon Nf square minus 1 upon Ni square, and this CH was also there. Cancel CH with CH. What we are getting? We will get a wavelength from this transition which should be equal to Rz square into 1 upon Nf square minus 1 upon Ni square. If we are talking about hydrogen, for hydrogen Z is 1. So what we are getting formula? 1 upon lambda is equals to R 1 upon Nf square minus 1 upon Ni square. So what is happening there? If from higher energy level electrons are jumping into first orbit, you will get different wavelengths. If coming from second, you will get light of one wavelength. Coming from third, you will get another wavelength. Coming from fourth, you will get another wavelength. So if you collect these wavelengths, you will get one series. This series is known as Lyman series. Means final destination is 1. From second, from third, from where they are coming. If final destination is second orbit, means electrons are jumping from higher energy level into second orbit. Again you will get one series. Which series is known as Balmer series. Balmer series. If they are jumping into third orbit, means from higher energy level they are coming in third orbit, you will get Paschen series. If they are jumping into fourth orbit, you will get bracket series. You will get bracket series. If they are jumping into fifth orbit, you will get Fund series. So they are asking problem related to these. They can ask, tell us the longest wavelength of Lyman series. How to solve this type of problem? You want to calculate longest wavelength of Lyman series. How to calculate? See, longest wavelength means shortest energy, because energy is reciprocal to wavelength. It means energy level should be minimum between two orbits from where electron is coming. In Lyman series, it is coming in two first orbits. So, nearest orbit is second orbit. It means electrons are coming from second orbit. So, what we will get? 1 upon lambda is equals to R, 1.097 into 10 to the power 7. Electrons are coming. Final destination is first orbit, but they are coming from second orbit. So, what we are getting? 1.097 into 10 to the power 7 into 1 minus 1 by 4, 3 by 4. So, getting my point? So, lambda is equals to 4 by 3 into 10 to the power minus 7 upon 1.097 meter. If you want to calculate in angstrom, multiply by 10 to the power 10, you will get this number in angstrom. Similarly, if you want to calculate shortest wavelength is related to highest energy. It means electron is coming from farthest orbit. Farthest orbit means coming from infinity. So, Ni is infinity and something upon infinity is 0. So, in this way you can calculate wavelengths. So, one more important thing is that if we want to calculate the value of, just we solved energy, this is this, En is equals to this, all are constant. If we will talk about, if in En we will talk about hydrogen atom, Z will become first 1. If we put N in place of N1, Zn and R1, we know the value of R and CH. What you will get? You will get En, means E1 for hydrogen atom. Easily you can calculate. Or you calculate the value of that, all other things. What we are going to do? We calculated there En is equals to minus RCH Z square by N square. If you multiply the value of R, C and H, this is energy because Z and N are dimensionless, you will get 13.6 electron volt. What you will get? 13.6 electron volt. It means if electron is in its first orbit in hydrogen atom, its energy is minus 13.6 electron volt. If you want to remove it, this state is known as ground state. If you want to remove electron from this orbit, you have to supply this positive energy. Means ionization energy of hydrogen atom is 13.6 electron volt. Hydrogen has one electron and it is moving in first orbit and its energy is negative 13.6 electron volt. If you want to remove it, give it energy so that it will become 0, so it can move now. So, getting my point? So, to ionize hydrogen atom, you need 13.6 electron volt of energy. It was complete about atoms. Now, we will discuss about nuclei.